Hello everyone and welcome back to another video, and today I want to show you guys my new project, Convex-TypeGen. So I started this project about a year ago, but recently I've gotten, in the last few months, a lot better at Rust, I feel, and I decided, you know what, I should rewrite this project and actually, publish it as a real crate. So that's what I've done, and I want to give you guys a quick little demo of the project and why I think if you use Convex and you enjoy Rust, you should give this project a try, and leave a star if you want. So if you don't know what Convex is really quick, it's a backend as a service that competes with Firebase and Supabase, and it has a lot of features like real-time updates, file storage, automatic caching, cron job scheduling, and many more things. You should definitely check that out. I'll leave links in the description to resources you can find. They also have an amazing Discord community, so feel free to join there. I'm going to assume that you have a little basic knowledge, and so I don't have to explain every single detail, but like I said, feel free to research yourself. But why should you use Convex-TypeGen? So the basic problem, or I guess hindrance that I found when using the default Convex Rust crate is that you really don't get any type safety. And so I thought, why not fix this myself? So as you can see in this code right here, client mutation, right? A mutation in Convex, you call this function send message function. This is just a string. You can misspell this and not really know until runtime. And also, you just pass in this B-tree map and you get really no type safety from this. And so I built this library to automate a lot of that process for you. What Convex-TypeGen does, it reads your schema and your function definition files, and it says, okay, we're gonna generate Rust types from these files. I'll dive into some code really quick and show you guys. I made an example inside of the inside of the project, and I'll show you guys a little demo real quick. So I can run this example, and it's gonna, have a little guessing game. And you can see we have the initial game status response, which gives us back this value. It might be a little hard to see, but you can see we have this loss count and win count. Now this is actually querying the actual database. If I go into this, my Convex deployment, you can see we have this game ID, this loss count and win count and creation time. And this is our actual table, right? And so it says, welcome to the game, the number guessing game, current record, 0 wins, 0 losses. So let's guess a number. Let's do 50, too high. Okay, let's do 25, too low. All right, 49. Okay, we got it in 6 attempts. That's cool, I actually won. So if we go back to the database, we can actually see that we have an update. Win count is now 1, right? Yeah, that seemed really simple. So let's dive into some code and I'll show you guys how that actually all works. Now the build.rs is very important because this generates our types before our project actually runs, right? And so we have 2 special parameters right here. Cargo run if changed, and this basically checks if our schema.ts file has changed or our games.ts file. So this is our schema for our database and our functions to mutate and query our data. And then we have this configuration which tells the convex parser where your function files are. And then we just run this generate function. And if anything in the generation fails, then we just panic because build files don't really get a print. Like it doesn't actually print data in the build file. So yeah. So if we go over to the convex_types.rs file, this is the auto-generated file that the library generates for you. So we can see this games table, right? If I put our schema side by side, you can basically see how the types convert. So we have the games table, which is games, and we have win count, which is a number, and loss count, which is also a number, F34, which is what the convex v number translates to. And then we also have our get game args, and this comes from our game.ts. So if we go to get games, we can see get game args, and there is no data inside the struct because argument is blank as well. And if I were to add something right now, like I can do let me just say name v.string. If I was to do v.string and I hit save, so if I do cargo build, you can see that we now have a name field inside of this get args. So just to make sure the code won't break, I'm going to delete this build, and you can see it now disappears after the next build. And we also have the function path parameter. So in Convex, if we go to functions and we go to get game, you can see that to actually run this function, we have to use the games namespace :get game. And so this is basically auto-generated by the library yet again. So all you have to do is pass in the function constant instead of this string, and so everything's type safe. All right, so now let's look at the main.rs, and this is basically the demo project for the guessing game. And here we're creating a normal convex client. We're making it mutable. And one of the things that the library does is translates Survey value types into convex value types. So there's a custom trait on the convex client called prepare args, and it takes in your argument that you want to pass to your query. So on the client.query, we have the get game args and then a function path. And then for the arguments, this needs to be a B tree of string and value, and this needs to be a convex value. Now the library by default returns a Survey value. So in order to convert that, you have to call prepare args on your struct, your auto-generated struct. And so once you do that, you basically have types compatible, and we go ahead and get the game response like we saw in the demo before. And if you do win a game, then we go ahead and create a new win game mutation, and we send that mutation off to convex. And if you lose, we also do another mutation, and we call the lose game function. And lastly, really quick, I want to go over the library code. So how the library basically works is it parses the JavaScript or TypeScript file. It generates an AST from that, an abstract syntax tree, and then from there, it basically converts that into Rust types. So when you call the generate function from the build.rs, we pass the configuration to this create schema.ast. And this basically generates a schema, which does a bunch of fancy parsing for JSON. And we have some validation in the library to validate the types, because these are the only valid types that Convex allows. So if you have any syntax errors in your schema, then this will fail. That's just to alert the developer and hopefully help you catch bugs. And there is a lot more code in here. Feel free to look through all this code. It's all open source. Now, if you find anything you can improve on or any bugs or suggestions, feel free to open a pull request. I also implemented this trait system for the Convex client. Again, my goal for this library is to make it really easy to interop with the Convex client and have a good developer experience in Rust. So I hope that's what that achieved. I hope this video was interesting to you. Again, leave the library a star if you want, and subscribe to the channel, and thank you so much for watching.